So I am. Looks like we've got a few people joining. Exciting stuff. Welcome, everyone. We've got, for those of you that haven't come to these before, there's the chat function. Most of you see that at the bottom of your screen, probably. Feel free to reach out during that. Maybe let us know why you're here today or what's on your mind. We'll give it until noon. Do others watch the Hallmark Channel, or am I admitting something that I should be keeping secret?
I don't watch very often, but I have a friend who normally watches, and I'm actually visiting right now and had hoped to watch them with her, but she's recovering from surgery. And she's like, no, I've already binged all of them. I cannot watch anymore.
Well, just so you know, in case of emergency, there is usually a premiere on Friday, Saturday, Sunday. So she can't
Okay.
have binged those already.
All
But if
right.
she's if she's recovering from surgery, too much cheese could be harmful to her health too. So we're at the top of the hour. It looks like we've got a few folks. I want to make sure we give people time to join us, but welcome to Charlottesville Women in Tech, our November event. If you've not been to one before, I hope you like what you see and you'll come back and join us again. Couple things I can mention, and we'll mention again before we get started too far, is this is being recorded. We asked folks about the best time to have events like this, and as you can imagine, we got many options from weekends to evenings to middle of the day to mornings before work days start. And at the end of the day, we're just not going to be able to make everyone happy with these, but we thought if we record them, then if folks can't make it at lunchtime because they're dealing with kiddos or at a meeting, then they can watch it at a time that's convenient. So keep that in mind if you're sharing that we're recording it, but we'll have it available for others. Another thing that I'd love to let folks know about is Charlottesville Women in Tech. Not everyone's always known if they're a member, but the fun thing is if you're on the mailing list, you're a member. But we've put some thought around kind of defining what that looks like. And we've got some really exciting membership opportunities, not more stress, not more payments, nothing painful, all good stuff. And you'll start to hear more about that starting in January, I think, somewhere around there. So keep an eye out for that. If you don't get our newsletters, if friend forwarded this to you or whatever, just go to our website, Seville Women in Tech, I think, and Katie can certainly correct me if I'm wrong, .org, or Google Charlottesville Women in Tech, and you'll see some options for ways to connect with us. And we're on Twitter and Instagram and all the fun stuff too. One other thing before we get started is there's going to be a December event, a little bit holiday, a little bit service, but an opportunity to volunteer. And the events group is pulling the final pieces together. So we may have some things to go out in the latest newsletter. Otherwise, keep an eye out on social for the details around that. Sounds like it'll be a fun opportunity. So it looks like we've got a few more folks now, and we're at 12:03, and I want to make sure we have a chance to hear all the amazing things that Leanna has to share with us. So let's maybe go ahead and start the official event. I'm Lisa Targonsky. I am very fortunate to work with Leanna. We're both at Elder Research. So I'm going to read her official bio because it's very impressive and fancy, and then I'll just share a little bit about how I see Leanna. So Leanna is a creative, data-driven problem solver dedicated to utilizing her analytic skills to improve the daily lives of others. Leanna enjoys researching innovative options to achieve goals and objectives and has experience employing her skills to solve real-world problems and influence policy. Leanna is passionate about the power analytics has to inform decision making. She's currently an analyst and data scientist at Elder Research with experience utilizing text analytics, statistics, network analysis, and unsupervised learning techniques across a diverse range of business problems and data structures. She's ardent about creating user-centric design through visualizations of advanced modeling techniques. As a data scientist, Leanna has managed engagements with several commercial and government entities. So that's the official Leanna. And I just want to add that I am fortunate to work with Leanna and be in a couple of different groups. And I think we all know women that are like the more quiet, strong, dependable leaders that are just always there influencing things in a really positive way. And Leanna does such an amazing job of that. So she's got these great technical skills and these great people skills. And I'm really excited to hear from her today. So with that, Leanna, I will mute myself and pass things off to you. Do you want me to read questions if they come up in the chat?
Yeah, that might be one way of working it. I was actually going to ask, I did design this so it has the opportunity to be interactive, for like
Right.
audience to speak up and answer questions in the middle. If that is something we think would work well, I can play into that. If not, I can just kind of leave pause for silent contemplation as well.
Yeah, let's encourage people to speak up if they feel like using their voices, to use chat if they feel like using chat, and we'll just see how it goes.
Okay, thank you.
Thanks.
So the talk today is meant to focus on how can we sort of refine our data visualizations so as to make the message that you're wanting to get across as clear and concise as possible, so it's digestible, preferably to a wide variety of individuals. So this is kind of the outline of what I had in mind. First, what this talk applies to and what it doesn't, because some of these concepts are not going to be universally applicable. They may take some extra time. So they're really for when you're wanting to make something very nice and you're putting it out into some sort of public space. How you can develop for this audience and identifying them, how to design with a purpose, which is going to be sort of the foundational concepts, and then building a visual essay, and then some tangible examples. So the examples will be that main time when there's going to be a lot of opportunity for, I'll kind of bring up a visualization and be like, okay, what do we think is good about this? What do we think is bad about this? How could we improve? So that'll be the key time for any interactivity. So as I mentioned, this is definitely loose guidelines. You don't always have to keep them all 100%. It's just something to keep in the back of your head and then use that to guide what you have in mind. So this is going to mostly apply to graphics that you're putting in for a presentation, a report, or a deliverable. So these are the things that you want to spend that extra time tweaking and making them look just right. And they're going to be accessed by the public or by people that may not be as well familiar with the data that you are presenting. This is not going to apply to your data exploration or your team updates or your dashboards. The data exploration and team updates, those are usually created a little more on a time crunch. You're not worried about taking the time to make it pretty and perfect, just to get the point so that you can digest what's going on. And the dashboards is more because a lot of what I'm going to be presenting are customizations, and they do take that extra effort to specifically write in an extra line of code and tweaking it. Do you want it this way or that way? And dashboards, given their interactivity, that's not always going to be a flexibility that's permitted in those spaces. So first, as this, I've talked about your teammates and your data exploration. So there's 3 different audiences that you might think about when you're building a data visualization. The first category is kind of a sketch type graphic. And these are going to be done more for yourself, your personal consumption, the data exploration. And the hallmarks of these is that you want to view any and all relationships, throw it all at the board, see what sticks. You're probably not taking extra time to do any formatting or labels. You just want to get an idea of where to navigate next. The next category would be refining these slightly for sharing with your teammates. So they do have some context for what's going on, but you will want to polish them a little bit more. So things like highlighting the key relationships so they know what to focus on, adding labels to your axes and your charts, and some moderate formatting, tweaking your legends, adding some colors. But the final category is considered publishing. So this is any time the graphic is going to be accessible by the public. Now, public here could mean just about anything. The whole point is you are not actively controlling who is viewing this. So if you send it off to your boss, but your boss intends to send this out to the whole team, you don't know who's going to see it and what context they do and don't have. So that is still going to be considered this publication category. So in these, we're again going a step further than what you might have with your teammates. You're going to focus on eliminating any extra clutter. You're going to be sure to add these extra data and context labels and any custom formatting. So this is commonly when you're building data visualizations, it might be considered annotations. That's going to fall heavily into this category. So designing with a purpose. I'm going to borrow heavily from some concepts from Edward Tufte, who is considered a pioneer in data visualization. However, I do want to caveat that I know Tufte can get a bad rap. He's mostly known for his concepts and his beliefs on chart junk and data ink ratio. And he's considered to be this hyper minimalist when it comes to data visualization. And so these examples here are what he's most known for in some aspects. These are his examples of a histogram on the left, a bar plot in the middle, and a box plot on the right. And a lot of people see this and they get sucked into this minimalist data visualization idea and they can't see further into the rest of the message that he has. And that is where we really want to focus. So I said, a lot of people get hung up on that ink idea, but really from Tufte himself, it's not about how much empty space there is, but rather how it is used. And so this is basically the idea that anything you are putting into your data visualization has to serve a purpose. If it's not serving a purpose, throw it out. And this image on the right is kind of a visual representation of another quote from Tufte on the idea of what it means to exhibit graphical excellence. So Tufte says, graphical excellence is that which gives to the viewer the greatest number of ideas in the shortest amount of time with the least ink in the smallest space. So most people are normally hung up on that least ink and think of him as a minimalist, but he's actually can be very maximalist in that he wants to maximize the amount of information that is conveyed, the number of ideas that a person can generate. So as that ink is that minimalist that a lot of people think of, but it's really that everything should have a purpose. The graphics, as he phrases it, should be high resolution and provide necessary context. So basically he thinks of it like a picture. If you have a grainy digital photo with large chunky pixels, you can't really figure out what's going on. And he envisions this as those HD visuals that have lots of pixels so that there is a clear picture. Another phrase from him is to clarify, add detail. So this isn't a minimizing the amount of information, just making sure it all has a purpose. So didn't click right. So the next idea is that maximizing the amount of information conveyed. That is again like that high resolution photo, making sure that there are lots of ideas. We generally have one message we want to convey, but there should be enough information so that they can form that message themselves, that they can teeter off and explore other options as long as it is related to the purpose at hand. And the last key component that he has was to minimize the time it takes to interpret a graph. And this is going to be the key feature in everything that I talk about today, is how can we minimize the amount of time it takes to interpret this? If you're spending a little extra time going back and forth and looking at this and looking at that to answer a question in your head, then there's an opportunity for an improvement. How can we make it fast? So one way to think of building these data visualizations is to think of it as building a visual essay. You're telling a story, but an essay may be the better concept here, because I know some people hear story and they think a little too grandiose. This can be very cut and dry, like an essay. And so the main processes that we want to think of as when I say build this essay, tell your story, you need to first define your thesis, provide evidence for this thesis, anticipate follow-up questions. So that's kind of like the next steps that you might offer in a presentation, and then edit. And the edit is kind of a circular arrow that will send you back to the top, and you'll kind of have to repeat this a few times to get it where it needs to be, just like you would write multiple drafts of a paper. So when I say define your thesis, when you're thinking of this, the thesis is basically the purpose of your visualization. You're designing this for some reason. What is that reason? What do you want the audience to remember? What should they take away at the end of the day? So some other ways to help you identify what you think your thesis should be is what is important. Is there an important data point? Is there a comparison? Is there a relationship? We care that these go up and down together. We care that this one is larger than the other. What is the important part? And that's going to be the main focus in your visualization. And this is going to be the thread that helps you construct throughout the entire process. So the next step is provide evidence. And this is really what we do every day when we build a data visualization. It is the content. What data is supporting your thesis? If it's supporting the thesis, make sure it's in there and highlight it, make it emphasized in some fashion. What data is superfluous? Like it's kind of there, but it doesn't really help. It's like, well, maybe they want to know, not sure. If it's superfluous and it's not directly related to that message you want told, either remove it or de-emphasize it. Which one can kind of depend on, if you want them to have some idea of what's going on with that relationship, then de-emphasize it. But if you really feel that it's a distraction and it's taking time away from reading that main message, then remove it entirely. The next is anticipate follow-up questions. So this is more thinking when another person is looking at your graph, what questions are they thinking about? And if you are able to have those questions answered within your data viz, then that's going to make it effective, strong. That's the legs it can stand on. So you should be able to provide enough data so that this graphic is self-sufficient. They shouldn't have to ask any other questions. If you're putting up your graph, but you have to tell a lot of story to even orient, then it's not really self-sufficient. It needs to stand by itself. Consider any additional evidence or context. So these are normally going to be things like your baselines, like, well, I can see the pattern of this thing over time, but what is historical? Is this actually low? Is this actually high? I only see this snapshot. Also, key reference points. So what are things that other people know very well? They have all that context. Well, can we add that reference point in to then help with those comparisons and relationships? And if you're doing any time relational line graphs, can you add any external information about key events that happened? What might have influenced these spikes or drops that you are seeing in the graphic? And then lastly, I said edit. So this is how you're going to polish it. You're going to make it extra shiny. And this is that step that really puts it into that publication for the public, whereas the other things are all important, even when you're building for yourself or you're building for your teammates. So the best way to answer yourself when you think of, is there anything else I can edit? How can I make this stronger? Is you need to make sure that your thesis should be clear and quickly understood. So going back to those points on the ink, the time, and the information, does all data serve a purpose? That's your ink question. If some of that data does not serve a purpose, find a way to downsize it in whichever way you think is appropriate. Is there any additional context needed? What more information can I provide to help them maximize the amount of ideas they can generate? And then what would make it easier or faster to understand? So minimizing that time. And any time that you have these questions that you think the audience is asking, and you see them going back and forth and it takes them a second to calculate it, that's the opportunity for improvement. So here is a random example. And so we're going to start with this toy of wanting to see what are the trends in phone types, in this case, over the past 5 years. This is as of roughly the end of 2019. And so this is kind of that first pass. This is actually what would come out of Google Trends. So this is the first pass. It's your data exploration phase. You're building it for yourself. What are some first ideas for what we could do to try and make this graph better?
So this is that audience engagement part, right, Leanna?
Yeah.
You're hoping folks will chime in or add
Yeah,
some
if
things to
not,
the
I'll
chat.
speak up in a moment, but give a moment that you can mull over and think about it.
Just want to encourage folks to speak up if you're thinking what you might do first here.
Hi, I just wanted to add, it looks kind of hard to like crunched, like it's hard to differentiate maybe.
Do you have any ideas on how you might make it easier to differentiate? If not, that's fine.
Maybe decrease the amount of time or something. I don't know.
That's fine. So I do have some steps and we'll walk through and kind of see what the impact of each decision is and how that's affecting the time, how much quicker you can digest the information. So right now it's kind of all a jumbled mess. You just see a lot of lines and you don't have that anchor point. You don't, everyone's going to ask, like when I said, oh, well, what's something that everyone kind of knows the context about? So this information was already in the legend, but let's pop it over. And so now you can kind of quickly see what are the points that everyone is most familiar with. And so it at least gets a little quicker to see what's going on. We mentioned that there was a lot of clutter, it's busy. So another way is to kind of black out what's going on in the background. So we're going to have, this is going to add further emphasis to those key points. So now we're not confused by all the colors on the screen. We just have a few key colors and there's labels with them. Or we can choose, take out all the extra noise. So we're just going to focus on Apple, Samsung, and Android. And we don't need to spend time looking at a legend since it's labeled directly. And then ultimately choosing to take away the part about Samsung, because that can also be other electronics and appliances. So let's focus on Apple and Android, which are two different operating systems. So we're kind of narrowing that thesis focus. And so there's no longer any distraction. You know that you need to focus on Apple and Android. But someone might look at it and have had those questions of, well, I see, went too far. I can see these spikes and these patterns, but what is causing these spikes? So this seems to repeat very regularly. With Android, we saw it kind of come to a peak and then fade off. What was happening at those points in time? So here we've added the annotations with the dotted lines and they are also color coded to match the main lines themselves. So you can see this is when Android was first released. So that's why there was no interest in it before. And it seems to peak with Android 4.0, but there isn't a repeating pattern that's happening with Android, probably more because it is an operating system than a phone. Whereas with Apple, we can see there's peaks with each new iPhone that is released. So going back to that original graph that we saw, first of all, we're making it visually. So this step one, create some sort of data visual. Add labels to your key items. That way you kind of get that reference and orientation. Highlight the areas of interest. This is one example. You could bold them. In this case, that kind of just makes it even more chaotic, so not always recommended. Or you can gray out or remove the points of non-interest, which is what we had previously mentioned. And then remove the legend. This is actually a really big point for Tufte, is that he says, if you're going back and forth to find the color in the legend and look at it in the chart, that is adding time to process the message. So if you can, at all possible, add your labels directly into the chart itself. Adding that color coding helps minimize that time of processing as well, and do away with the legend entirely. And then add any other necessary outside context. So now, before we were looking at just, this is a whole bunch of phone trends, but the thesis, what was that takeaway? There was no clear takeaway before. It was just thrown up to see what was going on. Whereas here you can see that we're trying to show that Apple has increased slowly over time and that they have this cyclical pattern that comes with each new iPhone release, and that Android is not as popular when it comes to Google trend results, and that really it seemed to peak with Android 4.0, but after that the interest seemed to wane in Android specifically. So that was the first toy examples. I have 3 other examples that we can walk through. So the first is tables. Almost every research paper you have, there is some version of a table, and you always have to sit there and you're crunching the numbers and going, well, what's the highlight? Is this one bigger, smaller? How much bigger? You're not really sure what's going on when you're looking at a table. So when at all possible, always make it visual. And this is where also that point I said before of like, this is going to be more for your final publications, less for your team updates. Sometimes you're crunched for time, and building these visualizations and customizing them takes time. So charts are not awful. They serve their purpose. But if you're trying to take it to the next level, making it a visual is going to help. So if we look, let me actually add context to what this table is. So this table was from a research paper. They were proposing a new clustering method. And so here they proposed, this is their method on the bottom row that they were proposing in this research paper. And these were pre-existing established methods. And they were testing it across 4 different data samples. So MNIST, which I think is the numbers, and you try and predict it, it's at a 0, a 1, a 2, a 3. I'm not familiar with the other data sets off the top of my head. But when we look at this visual, do we have an idea for what the takeaway is supposed to be?
The fact that the bottom row is bolded, it suggests that I should be paying attention to that row, but I don't really have a good sense of what that means.
Yes, so they did want to highlight their method, and they are trying to claim that their model does better than these other ones up above it, and is doing better across several different data sets. Because we do sometimes know that methods are best in certain use cases, but they're not universally applicable. So they're trying to say that this is better, and it's better across multiple data sets. So when we're looking at this, when I said kind of anticipate those questions, what are the calculations a person might be doing in their head? What do they want to gain from this? So some questions that they might be asked, the audience might be asking is, which data set does each method perform the best or the worst on? For each data set, which method has the best or the worst performance? So kind of which angle we're anchoring from. How much better is their method? They're saying it's better, but is that a notable margin or is it negligible? So one way we might choose to adjust this is grouped bar plot. We will move past this, just this is kind of a first evolution of what you might be thinking in your head. I need to make it visual, what can I do? So we did say we were caring about, well, what's the best in this category and the worst in the other category. So grouping it when you're making it visual is going to help. And because we do care about magnitudes and the sizes of difference, then a bar chart can make sense. So this also, I want to also say any visualizations that I present in this, with the exception of one, which I'll highlight when it shows up, are all done with R and ggplot, really just to the point of saying all of these things are accessible, even if you're not necessarily familiar with them or they take extra effort to generate. So in this case, this is a facet grid applied to bar plot. So with this, going back to those anticipated questions, which data set does each method perform the best or the worst on? So in this case, that's a little difficult still, because while the bars are the methods and they are color coded, you have to take a little extra time hopping from here to the next one to kind of gather, this is the value on this one, remember the value on the next one. You're kind of like mentally building that stack and saying, this is the highest value, that's the highest value, and replacing it as you go left to right. So it's still taking some extra time to process. For each data set, which method has the best or the worst performance? That we can see when we stay within an individual bar chart. We can quickly see what is the highest bar, and we can also see the margin of difference between it and the next highest bar to answer that question of how much better is a given method. So this is an improvement over the table, but not really where we want to finalize ourselves. So this graph, I know it may look a little different at first. It is considered a lollipop graph or a dumbbell plot. So in here, we have our different methods on the left, just as we did in that chart. And then each of the data points are the different data sets. So, and they're color coded. Unfortunately, rooters and rooters 10K do tend to overlap. So if you're wondering, why don't I see a green dot? That's why. But you can quickly see, okay, this is the range of all the purple dots. You can see how this is the range of pink dots. You can say within an individual method, which dot is the furthest out, how much further out it is. And we've also kind of like how they bolded their method in the chart. We've added this box to the bottom one to kind of highlight this is what we want to be focusing on. So repeating some of what I've just said, the aesthetics of what we've changed. We removed that legend and had the color-coded dots instead. Removed the background, which is really just that gray background that you got from the facet grid. That's a really big point for Tufte, not really that big of a point in my mind. And we emphasized the key group with that black outline box. those questions that we had in mind of like, what's the biggest, what's the smallest, what's the margin of difference? So it's now easy to compare the method across the data sets, which is each individual bar. And it's easy to compare data sets across the different methods, which is then looking at this kind of vertical display. This visual style can also be very helpful when you're looking at different models. So you have, I tested a logistic regression, a decision tree, and a neural net. And I'm most interested in F1, but we may normally settle on F1 or accuracy because it's simplest to focus on one. But this is a way that you could then have, as each of these individual dots, you can have your precision, your recall, your F1, and your accuracy across all of the different models that you built, and you can see it all very quickly without having to have a table. And so now back to that takeaway, they were saying theirs was better. And so once you can see it more laid out visually, you raise the new question of, is it really that much better? Like, it is technically higher on each of these color points, but it's only marginally higher on the MNIST and the STL hog data sets. The main difference seems to be the rooters and the rooters 10K. So it then kind of puts that information more readily that you can make that decision of, is it actually better? So this next example, this one's ugly. I'm aware it's ugly. This is embarrassingly my own graph that I have given to a client. And I gave this within my first 6 months of working for Elder Research. I was in a time crunch. I did not know that the delivery was to a client. You learn. So just to orient you, and my point as I'm going to talk through this is the fact I have to orient and say all of these things that are not self-sufficient within the graph is a quick and easy way of saying this graph has opportunity for improvement. So in this, we were looking at tweets that were coming out about the word touchdown, specifically looking at the time frame of the Super Bowl. I don't remember which number, but Super Bowl. And so we wanted to see if we could create a method that would flag when these touchdowns happened based on tweet volume without having to actively not wait in this case, but watch the television. So we wanted quick real-time alerts. So here in the black was the tweet volume, red was the actual alert that we would have set off, and the blue is kind of like a continued alert, like the alarm would go for a while before it turned off. So I said, not very clear. So one of the first things that we can do is kind of take a step back. Let's get it down to the bare bones. Well, yes, the takeaway is the method good at flagging the time it takes based on the tweet volume. And the questions that the audience might be asking, when were the actual touchdowns? Like, we see when the tweet volume is, we see the peaks, but like, when was there a lag? When did the real-time event happen? What do these different lines indicate? There was no legend in this original plot. And are these alerts really late? Are they early? Do they happen smack dab right when the event happens? So as I said, going back to bare bones. So first, it was tweets per second in the other graph. We don't really need that per second information. It's making it kind of very staticky and just adding that extra noise. And really all we needed to see was the pattern over time. So here I've smoothed it down to the tweets per minute, and that just makes the line itself, the volume, easier to digest. I did want to, just a completely random side note here, there are extra tick marks here. If you cannot provide what you need to do in Python, whatever coding platform you have for publication graphics, it is feel free to edit it in PowerPoint, edit it. Tufte always recommends Adobe, which I know is not actually accessible to all of us. But R hates time units, breaking it up, not easy. So I actually just manually added these extra sub tick marks in here, but that makes the time units easier to tell in this graph. So feel free to add after the fact or erase. So here we now have this volume over time. We're going to add reference to real-time events, but we're first starting with just that frame of reference. When did the game kick off and when was halftime? So when was the key range of action where touchdowns could have even possibly happened? So there was still volume of tweets about touchdowns into halftime and even a little bit before the game kickoff. Next, we're going to add when the actual touchdowns themselves happened. These were the real world events that we were interested in. And then adding, instead of those individual lines that were happening, just kind of add a grayed out region, or in this case, red, to indicate the period of time over which the alert might have happened. So with these modifications, we've gone over some of these. We've smoothed the plot, the external references to the real world events. So when the actual touchdown happened, when the game started, when halftime started. We no longer need the legend. Before there was a color-coded red line, blue line. We don't need a legend this time because we've added the annotations directly onto the chart itself. And those questions we had before, we can now see how an alert lines up with the tweet volume, and you can see the delay between the event and the alert. So that's kind of this white space between an actual touchdown and when the red begins. So with that, we were previously saying, oh, our method is great at real-time flagging. So now with these modifications, we can more effectively say our method is able to flag increases in volume within 5 minutes of real-world events. And this 5-minute part is kind of why I brought up these minor axis ticks. And that's because before, if this was only marked at a half hour, trying to get smaller units of time is hard to decipher. You can say, well, it's less than 15 minutes. So this will kind of give that extra reference point to make that mental calculation easier. So this next example, this is a graphic from a research paper about grapes. And the focus of their paper was the genetic structure and domestication history of the grape. And here, this is an exploratory graph where like there isn't a thesis in the sense of a persuasive essay might, where you want to say, this is the point, like take this away, I'm going to argue that this is true. This is meant to be more of just, hey, what do you see type of graph. And so with an example like this, you do still need to create a key point to help them focus with what is going on in your graph. So having gone through the paper, their intent for this graphic is to understand how your favorite wines are related based on the types of grapes and their genetics. But when we look at this graph, there's a couple of issues with it. First, the lines are super bold. They're kind of the main focus of this, that you lose sight of the grapes themselves, the nodes in the graph. The labels are small and hard to read. So even if you wanted to pick out your favorite grape, you're kind of squinting to see all of that information. There's not a reference point for the audience to latch onto. If these grapes were marked larger, you could maybe pick out your favorite grape and orient yourself that way. But right now there isn't kind of one spot to start and figure out how you want to focus besides saying, I'm going to start at the center, and then you're kind of like lost in a maze. And the clusters of entities are difficult to distinguish. So like we can see that there's a group here and a group out here and here, but trying to decipher if they have overlap can be a little difficult. So this modification comes from Jonathan Coram of the New York Times. And this is from he has a talk on designing for your audience. And so in this example, he created this chart. I did add after the fact onto these color codings of these individual dots on top of it. So that's a aftermarket edit that's done in PowerPoint. So in this case, some of the aesthetic changes that were made by Mr. Coram is he's changed those bold lines for the relationships into a light gray with a thin line weight, which makes the entities, the nodes of the grapes, easier to focus on. The labels for the grapes, the names of them have been made larger and they are therefore easier to read. He has bolded the most commonly known grapes for wines that people might like. So that helps them orient themselves and find what they may be interested in more in a timely fashion. And the color coding on the different branches kind of helps you understand the families of grapes a little clearer. I don't have to look at this one and trace its line to see if it's related. I can tell by the color that they exist within the same kind of family. So getting towards wrapping this up, last example we have is to remove the unnecessary. That's that editing concept. So in fashion, it's commonly quoted from Coco Chanel, before you leave the house, look in the mirror and remove one accessory. That is editing. If you ever watched Project Runway, they always talk about, you needed to just edit your ideas a little more, which is their way of saying you have too much going on, pare it down. So that is what the remove the unnecessary concept is. So bringing it back around with Edward Tufte again, this is a classic example from him on chart junk. And so this was, I don't remember the context of the graphic on the left, but it was like an advertisement or a USA Today type of graphic where they added a lot of extra flourish. But that flourish doesn't tell the story. What is the purpose of that flourish? The purpose is comedy. And if that is your thesis, that's fine. But if your thesis is, I want to show you that things went up over time and they came back down, this drawing of the woman is a distraction. So remove anything that's unnecessary. And so kind of as a handy checklist that you can take before you deliver any final visualizations, here are the things to think about. Can you make it visual? First and foremost, if it's in a table, do away with the table, try and make it into a graphic of some sort. Add annotations instead of legends. Add any outside context, so things that may not exist in your original data set but might add extra information. Emphasize your point, de-emphasize other points, remove any extra noise that's going on, polish your axis and chart labels. So this is, I didn't touch on this as much, but that's that bolding, the font size, any word wrap that's going on. And these last two examples are going to apply more for presentation. And so those are, can you build it in a sequence? Like we did with that touchdown graph, we started with just, this is the volume of tweets. We then said, this is when the game begins. These are the touchdowns. These are the alerts. So building that sequence can help orient them so that when the time comes to view the final graph, they already have that context and they can get the message faster in the final. And then anticipating their questions. So this is also not always just in your visualization, but if you have any questions that you know are likely to be asked, think about those so that you can at least verbally answer them. If they're slightly not unrelevant, but less relevant that they didn't need to be included in the graph, but someone could ask, anticipate those, have those on hand when you're giving a presentation. And these are the different works that I referenced in building this. Are there any questions or thoughts?
This was so wonderful, Leanna. I see a couple of comments coming in here. Um, this was a great webinar, another resource to take. What we've learned here and expand. The following book has been helpful. Storytelling, a workbook, Storytelling with Data, a data visualization guide for business professionals. Um, and Storytelling with Data, let's practice. So that's a great tip. Thank you for sharing that, Shannon. Courtney is asking a question. I had the same one. What are your favorite data visualization tools? And I know you talked about R and ggplot, but I'm sure you've used others with clients. What are some of your favorites?
I actually most prefer R and ggplot. I've used Tableau or any of the like Power BI. My personal stance is that I always want to do too much of this custom tweaking, and it's good for an initial start. There's not a lot further that you can do, especially if you want to do the sexy, like those just aren't things that are in these boxes. Python, I don't like. I feel like you have to specify too much just to do the basics. Unless you're using, say, Seaborn, they tend to look kind of clunky. So I will often even take my data that's in a client that has to be Python, and I'll port it over into R just so I can get the aesthetics that I want for a visualization.
That's great. Do others have questions or other favorite data visualization tools or resources? You're welcome to unmute and just share your question or put it in the chat. Another question I had, Leanna, and maybe this is a little off topic, but I was thinking about it, is I've I've tried to convey information to mixed audiences where some folks are very data savvy and um, are really analytic and want to dive down deep and understand every little bit, and other members of the same audience just want the facts, just the top level. Do you have any tips for how to find that right balance when there's kind of a broad audience?
So my take would be you want that extra information for that person who's going to dig down. So you do have it provided, but this is where layering, but thinking of it more as like when you screen print, you have layers, there's a base and then there's the next layer and the next layer. So there's kind of like the base of the data points, and then there's your color coding, and then there's your annotations. So having that extra super detailed information kind of there, but lower in the prominence. So that way the key points are more emphasized so that those individuals that want just the highlights can get that faster. The way Tufte phrases this is macro and micro readings of a graphic, and that he believes that you should be able to kind of see micro relationships between things and get all those small little details and get that big picture all at the same time. And his favorite example of this is actually maps, and that maps contain a ton of information, but you can also see where the roads are or like where the mountains are very quickly and get an idea for the basic navigation.
Yeah, I love that description and thinking of maps in that way. Thank you. I want to give other folks a chance for questions, or if there were pieces that you really like and just want to hear more about. My husband and I used to do this thing where we would just be silent for 7 seconds and just make it really uncomfortable, and then someone would inevitably ask a question. Okay, I'm going to ask another question then, or maybe just I'm going to kind of have you confirm or refute what one of my main takeaways is from this. It really so we all looked at a couple of the graphs that you showed us at first and cringed a little bit, like they were uncomfortable, they were difficult to digest, and what I'm hearing from you is that there are ways to make things easier to digest, to really get the message across. But in that process, you're also allowing the story to be more persuasive to the audience. You're not only making it cleaner, but you're helping your clients hear what you want them to hear. Is that fair for a takeaway for me?
Yes. So when this was actually first drafted, it was meant for delivery to clients, in which case we are normally trying to persuade and go, this is the point, focus on this, go this way. So yes, persuasion is kind of where this is most valuable, but it is still helpful, as we saw in the grapes example, to still try and clarify and refine. But the persuasion is definitely, yeah, you're trying to lead in a certain point, which is actually where I disagree with Tufte. Tufte is very hands-off and you should not be persuading. He considers it a contempt for the audience. So, but yes, I would say persuasion is definitely the point.
Interesting. Tufte's thoughts on that. Yeah, and when you show me pictures of grapes that are used for wine, it's just persuasive as it is too. So
You just need to go home. See if you
okay,
like
I want
this
to,
one and that one.
yeah. I want to make sure folks have a chance to chime in with any last thoughts or aha moments. I'm really glad so many of you were able to join us today for at least part of the session.
Hi, Lisa. This is Sheree. Can you hear me?
I can hear you just fine, Sheree.
Perfect. Leanna, that was an awesome presentation. Um, and I want to ask you for people who may not have been doing this for too long, or they now have all this newfound knowledge, how much time would you recommend that one spend? Or as you're working on the project, how much time should we allot to visualization, in your opinion?
That is a good question. I would say one of your first thoughts should more be if you're thinking broadly, you probably need to allot more time than you think, because of that iteration process. I can't broadly give a specific answer, but when it comes to gauging how much, like, should I do a little, should I do a lot, that I think is really coming down to what is the audience and are you going to be able to hold on to this item? So when I'm doing just a stand-up meeting, so sprint, if you're doing agile, those, I would say an hour, maybe two, depending on how many pieces you're trying to present. But an hour is usually sufficient to try and do your axes graphs, kind of color code and get your titles and everything. But if this is something that's going to be like final in your deliverable, it's the last thing you're handing off and other people won't have access to you to ask any questions. Those are where you're going to spend a lot of time. And I would say, depending on what you are trying to deliver, a minimum of an hour up to 3 hours per visualization. And that can sometimes just be the time it takes to figure out how to make the code do what you want it to do. But honestly, in building that Lollipop graph, that was probably the first draft version of it. Could have been several hours, most of a day to get that done. But now that I have a template, I can go back to it and that will also shrink time. Does that somewhat answer your question, Shree?
Absolutely. Awesome. Thank you. I think that iterative process is what I really wanted to draw out, is that it's not a one and done. Sometimes you need to kind of keep going back. And typically you end up investing more time than you initially thought you would, but it's time well spent.
Yes, just a good example with that. I had these examples previously generated and gave this talk before, but I demoed it to a friend last night just to get used to it again. And she was the one that was like, you say you can do this in under 5 minutes, but I can't tell if that's 5 minutes looking at that chart. You need to add minor axis ticks. And I did try and figure out how to make the code do that. I spent about half an hour, couldn't figure out how to do it, and then put it in PowerPoint. So iterations, getting extra feedback definitely is a big point.
I love that. That is a good friend that will tell you you need more tick marks in your life. That's
Yes.
fantastic. Well, we are almost at the top of the hour. Leanna, thank you so much for sharing your expertise with us today. I really value the time and what we've learned here. People that were able to join us, thanks for coming along for the fun. We will have the video of this made available. I believe that'll get sent out to you. If not, you'll see it on the Charlottesville Women in Tech channels. And be on the lookout for a December service event and a January membership kind of unveiling and little celebration. So enjoy the rest of your day.
Thanks, everyone.
Bye.